Hi there, Sam here from Xmrit. I wanted to record this quick video as we've just released a couple of new features that are going to be really useful for you in your XMR journey. These are the trended limits features and the deseasonalization features. And these are really useful for dealing with trended and seasonal data types that are really tricky to deal with on traditional XMR charts. The manual at xmrit.com, just up here, has an extensive and detailed information on the new features and how they work. And it also goes into detail about the underlying mechanics if you're really interested to understand how we do what we do when we do trended limits and we do deseasonalization. But let's begin. Why don't we start off with some trended data and understand how Xmrit deals with it. So on the screen now here is some trended data. Pretty simply, it is a data with a downward trend, and XMR charts often have this problem where trended data looks like it's exceptional. And in some sense, it definitely is. It shows a trend is occurring. And in this case, both ends of the trended data are being identified as exceptional variation, breaking both ends of the process limits. In some cases, that's useful. You want to know if there's trended data because that is exceptional variation for you. But sometimes the trend is ongoing, predictable, and knowing there's a trend occurring doesn't help you, and it can obscure you trying to find the exceptional variation which is hidden from you on this XMR chart. The way we now deal with this is with trended limits. And it's very simple. Working just like the lock limits button, you can now trend your limits alongside your trended data. Simple as this. You click on the trends button and press trend limits. And voila, you now have trended limits that go alongside your data. Now, the way this works is pretty simple. We generate a simple linear regression based on the data in this pop-up, and it's pre-populated with the data already existing in your Xmrit table. Nice and simple, and it uses the traditional y equals mx plus c equation that you learned in high school or secondary school. If you need more information on linear regression, I recommend visiting the Wikipedia page that we've linked in the manual. Now, there is one trick to this that's sort of important to understand. It is determining what goes into your linear regression and what doesn't. Here's an example of this. This data has an obvious upward trend, and then what appears to be a flattening that occurs around here. You can tell this because there's the exceptional variation at the bottom here, and that these points do not cross over the upper top of the process limit, while these points are being caught by the quartile limit. The problem with this is if we click on the trends button and we trend our limits using all the data, no exceptional variation is detected. This is because when you're building your linear regression, it includes these bottom points that were part of the flattening off. That means your trended data cannot detect, your trended limits cannot detect the exceptional variation for the one we think it is. However, if we remove that flattening off period and we say to ourselves we want to see, we remove this portion of the data in our trended limits and we use it just based off this data and see, does the trend continue? We can immediately see the exceptional variation clear as day. By only including this portion of the data set in our trended limits, the exceptional variation when we think there's a flattening is much clearer to see. Now, the second feature we have is seasonality. Let's look at some seasonal data. As you can see here, this is 3 years of data, well, 2 years and 3 months of data. And what we can see is there is a strong seasonal pattern. January starts out low, December starts out high, and there is an ongoing trend upward throughout the year with a flat portion here. Now, the problem with this, as you can see, is the seasonality in our data has made very wide process limits, meaning it's very hard to know what's going on. And the MR chart has this silly effect where because January is always so much smaller than December, you have these huge jumps. But this may be expected behavior and doesn't help us to understand what's going on. We need to be able to remove the seasonality before we can analyze our data. To do this, we have the seasonal data button. just alongside the Trends button. Click on the button, press Deseasonalize, and now we have this data is now deseasonalized, and we see this portion here of exceptional variation in year 3. Let's have a look at that in more detail. We can see that year 3, January, is significantly higher than year 2 and year 1. Same with February, which is higher than both year 1 and year 2. And year 3 is significantly higher again than years 1 and 2. We couldn't see this in the original graph, in this current graph, because it's masked by the exceptional seasonality in this data set. Only by deseasonalizing it do you get visibility on this. Now, inside the manual, we talk about a bit more how we do deseasonalization. I won't go into much detail here, but you'll note we use a method called seasonal factors, and that's indicated by these colors, which link to the seasonal factors on this table here. For more information, go into the manual. The last thing I wanted to tell you about the seasonality feature is the period selector. Now, when you look at this seasonality, you can see that it occurs annually. What that means is that every January is low, every December is high, and the pattern repeats over the year. But sometimes these seasonal patterns repeat over different time lengths. The most common ones you find in business are weekly, monthly, quarterly, and annually. We have built all these types of seasonality into the tool. So you go into seasonality and you can select quarter or annual. In this case, you can select quarterly or annually because you've only got the data at the monthly level. You can also, however, if we select a different type of data set, in this case we have 2 months of data, you can detrend it at the monthly level or the weekly level. So if we deseasonalize at the month level, we get a deseasonalized graph in that fashion as well. This is useful because you might have data that repeats monthly, say order volumes at a factory, or weekly, for example, footfall in a shopping mall. If you want to understand how the calculations are done, you can go to the manual. Inside the manual is this Excel spreadsheet, which goes into detail of each of the 4 types of seasonality with a worked example. Thank you so much, and I hope you look forward to using Xmrit and these new features. If you have any questions, please feel free to email me at sam@xmrit.com or reaching out on the feedback form at the bottom of the tool. Thank you.